Question number 7. Estimate f of 5. So first, find x equal to 5. Draw a vertical line here and see where it hit your graph. It's this yellow dot. You want to know its y value, so you draw a horizontal line. It hit y equal to 2, so f of 5 is 2. That's part A. Part B, estimate the x values that made f of x equal to 1. So f of x is just the y value. You want to find first y equal to 1. That's a horizontal line here. And you can see there are 2 dots for the intersection point. So you want to read the x value for those 2 dots. First one is like this. So it hit the x-axis at between 4 and 5 and closer to 5. So maybe 4.7. So for this one, x equal to 4.7. For the second dot here, if you draw a vertical line, it hit the x-axis between 9 and 10. Maybe 9.3 or 9.4, something like that. So those are the 2 x values corresponding to y equal to 1. That's part B. Part C, the horizontal intercepts. So that means the graph hit the x-axis. So if you look at the graph, here is the x-axis. So it hit, the red curve hit it at 2 points. Those 2 points. And you want to read those 2 points. For this one, the x-coordinate is between 4 and 5. Maybe 4.5. So 4.5 and the y-coordinate is 0 for the horizontal intercept. So that's the first point. Second point is here, its x-coordinate is between 9 and 10. Maybe 9.5. So for the second point is 9.5, 0. That's part C. Part D, the domain and the range. If you look at the graph, it's a parabola. So it's a quadratic function picture. So you know the domain and the range from there. So the domain for the quadratic function is everything. So it's negative infinity all the way up to infinity. For the range, this parabola opens down, so it has a maximum point. It can reach any height down here, but up there it can only reach a height at y equal to 6. So it's negative infinity all the way up to 6. We use a square bracket here because 6 could be reached. It could be reached at this vertex point. So that's the range. Number 8. Estimate f of 9. First find x equal to 9. So it should be here between 8 and 10. If you draw a vertical line here, you can see it hit the graph at this yellow point. And you want to read its y value. So you draw a horizontal line, it hit y equal to 4. So you know that f of 9 equal to 4. That's part A. For part B, you want to know the x values that make f of x equal to 6. So basically, you want your y value to be 6. It should be here, y equal to 6 between 4 and 8, so it's here, y equal to 6. And it hit the graph at 2 points. And you want to read those 2 points. For the first point, if you draw a vertical line, it hit the x-axis at 0. So that means the x value is 0, y value is 6. So that's the first one. For the second one, if you draw a vertical line, it hit x equal to 10. So that means when x equal to 10, f of x is also equal to 6. That's a 2 point. Part C, horizontal intercept. So horizontal intercept means where the graph hit the horizontal axis or the x-axis. So your x-axis is here. So those 2 points are the point you are interested in. So you want to read this. For the first one, x equal to 2. So it's 2, 0. For the second one here, the x value is between 6 and 8, maybe 7. So 7 and 0. That's the second point. Domain and the range. So for the domain, if you look at the points on the graph, it can go to the left and to the right, any places it like. So for the domain, it's every real numbers. So that's negative infinity to all the way up to infinity. That's the domain. For the range, if you look at the points on the graph, it can go very high, but it cannot dip down under this height, which is -6. So you know that the range should be -6 all the way up to infinity. Again, -6 should have the square bracket because y equal to -6 could be reached at this minimum point here. That's part D. Okay, number 9. Alpha f of x is 3 to the power of x. Find the inverse function. So we know that for the exponential function, its inverse is a logarithm function with the same base. So the inverse function here should be log base 3 of x. And part B, complete the column of fx and the other columns. Let's do f of x first. So f of -1. So if you plug in x equal to -1 here, it's 3 to the power of -1. So that one is 1 over 3 to the power of 1, which is just a 3. So the final answer is 1 over 3. That's the first one. Second one, if you plug in 0, is 3 to the power of 0. We know that anything to the power of 0 is just a 1. So f of 0 is 1. Then f of 1 is 3 to the power of 1, which is just a 3. F of 2, that means 2 of the 3's multiplied together, which is 9. F of 3 is 3 to the power of 3. That means 3 of the 3's multiplied together, which is 27. So that's how you get this column here. Then it wants you to use the knowledge of inverse function to complete the last 2 columns. Okay, you want to complete those 2, but with no further calculation. Just use the inverse function knowledge. We know that for the inverse function, its new y will be the original x for the original function, and its new x will be the original y. So this column x will be the same as this y, which is the f inverse of x. This original y will be the new x for your inverse function. So those 2 columns will be the same. Now you are ready to copy everything here. So that will be the new columns. So that's part B. Part C, they want you to sketch f and f inverse. They also want you to include the line y equal to x, because you know that your function f and f inverse will be symmetric about this line. You'll pick any 6 point on the graph of f and f inverse. So what I pick for the f will be 3 points shown here from the previous table, but not including those big numbers. So that will be the first 3 rows. For the f inverse, I'll do very similarly, the first 3 rows. And then I want to label them on the xy coordinate. So for example, for the function f, the first point is -1 1/3. So -1 is somewhere here, 1/3 is somewhere here. So that's this point. For the second point, 0, 1, 0, 1. So it's this point here. The last point, 1, 3. 1 is here, and the 3 is up here. So this is exactly that point here. So if you connect them together, you kind of know what does F look like. Very similarly, you can draw F inverse. So this is how I connect them. So this is the original function, this is the inverse, and this is y equal to x. You can label everything here. For this picture, you can see that your original function and the inverse function are symmetric about the line y equal to x. Another thing you want to pay attention is when you draw this end, it's getting closer and closer to the x-axis, which is this line here, but never intersect with this one. Also for f inverse of x, this end is very similar. It's getting closer and closer to the y-axis, but never intersect with that. So you should be careful when you draw the picture for this. Okay, so that should be the answer for part C. Number 10, very similar question. For the f of x equal to 4 to the power of x, its inverse should be the logarithm function of the same base. So log base 4 of x. And then you want to complete the column here. So first, x equal to negative 1. F of negative 1, if you plug in the original function, it will be 4 to the power of negative 1. It's 1 over 4 to the power of 1, which is 1 over 4. Second one, f of 0, 4 to the power of 0, which is 1. The third one, f of 1, 4 to the power of 1, which is just a 4. F of 2, 4 squared, it's 4 times 4, which is 16. F of 3, 4 raised to the power of 3. That means 3 of the 4s multiplied together, which is 64. And then you want to fill in the x and f inverse of x. Again, you know that your original x will become your new y, or say f inverse of x. And your original y will become the new x. So that's how you copy those two columns to your new columns here. So that would be for part B. For part C, they want to sketch f and f inverse and include y equal to x. For the 6 points I choose, again, I want to choose the points with small numbers, which is easier to draw. So for the original function, I choose the first 3 rows. For the f inverse, I also choose those 3 rows. And then I want to sketch them on the picture. So for example, for the original function, first point, negative 1, 1 over 4, it is here. And 0, 1, it should be here. And for 1, 4, it is up here. For the f inverse, you can also draw those 3 points. And then you want to connect them to get your picture. So for the function f of x, it should be here. And for the function f of inverse, it should be here. And y equal to x is in the middle here. So you can see your picture, f and f inverse is symmetric about the line y equal to x. And again, for f of x, you can see at this end is getting closer and closer to the x-axis, but never intersect with x-axis. For the f inverse, similarly this end, getting closer and closer to the y-axis, but not intersect with y-axis. So you should be careful when you draw the picture.